Dear students, let us continue Module 3. In this lecture video, we will be studying the need for optimization. Since Internet of Things will largely be built on Internet Protocol suite. To make Internet of Things work properly, a large number of Internet protocol should work. In coping with integration of non-IP devices, may need to deal with the limits at the device and network levels that IoT often imposes. So in IoT, so many IP devices, non-IP devices, they will be working in integrated form. So we need to take care of everything, all the devices properly. Therefore, optimizations are needed at various layers of the IP stack to handle the restrictions that are present in the IoT network. So, optimizing of protocol, optimizing of applications at various layers of the IP stack is needed. The following concepts take a detailed look at why optimization is necessary for IP. The following concepts take a detailed look at why optimization is necessary for IP. Constraint nodes, the different concepts used which will clear why we need optimization of IP is constraint nodes, constraint networks, and IP versions. Now, constraint nodes. IoT having different classes of devices coexist. Different classes of devices in the sense of some things have more storing device, some things which have less storing device, some are fast in processing, some are slow in processing. So different types of devices exist together in the IoT. So depending on its functions in a network or thing architecture, or may not offer similar characteristics compared to a generic PC or server in an IT environment. So all the things may not work properly or in the same way how general PC or server work. Another limit is that this network protocol stack on an IoT node may be required to communicate through an unreliable path. So all these network protocol stack on an IoT node may be required to communicate through an unreliable path. Even if a full IP stack is available on the node, this causes problems such as limited or unpredictable throughput and low convergence when a topology change occurs. Power consumption is a key characteristic of constraint nodes. So this is another thing. Constraint nodes means power consumption. Some the devices which consume less power. Battery enabled with lifespan of months 10 to of months. So this is another characteristic of the constraint nodes. So battery life for constraint nodes may be from 1 month to 10 years. Battery powered nodes impact communication intervals. The node one that is always on, instead another option is always off, which means communications are enabled only when needed to send data. So some nodes are always on, some nodes will always be off, but communication needed, it is enabled for sending data. IoT constraint nodes can be classified. The different classification of constraint nodes are first classification is devices that are very constrained in resources may communicate infrequently to transit a few bytes and may have limited security and management capabilities. These devices, the need for the IP adaptation model where nodes communicate through gateways and proxies. So those devices which have limited resources to the storing device may communicate infrequently to transit a few bytes and may have limited security and management capabilities. Another classification is those devices with enough power and capabilities to implement a stripped down, strapped down IP stack or non-IP stack. In this case, you may implement either an optimized IP stack and directly communicate with application servers, or go for an IP or non-IP stack and communicate through gateways and proxies. Next classification is those devices that are similar to generic PCs in terms of computing and power resources, but have constrained networking capabilities such as bandwidth. So those devices which are like PCs and good in power consumption, but they have limited networking capabilities and bandwidth. So these nodes usually implement a full IP stack, but network design and application behavior must cope with the bandwidth constraint. In constraint nodes, the cost of computing power, memory, storage resources, and power consumption are generally decreased. It is less. At the same time, networking technologies continue to improve and offer more bandwidth and reliability. At the same time, networking technologies continue to improve and offer more bandwidth and reliability. A constrained network can have high latency and high potential for packet loss. They have high latency and high potential for the packet loss. Constrained networks are often referred to as low power and lossy networks. So another characteristic is constrained networks have low power and lossy networks. Constrained networks operate between a few kilobytes per second and a few hundred kilobytes per second and may utilize a star mesh or combined network topologies, ensuring proper operation. In constrained network, it is not unusual for the packet delivery rate to oscillate between low and high percentage. These are the all characteristics of the constraint nodes. It may lead to work on optimizing protocol for the IoT. Next topic is the IP version. IETF has been working on transitioning the internet for IP version 4 to IP version 6. IETF, it is a task force which is working to transition of IP from version 4 to version 6. The main driving force has been the lack of address space in IP version 4 as the internet has grown. IP6 has a much larger range of addresses that should not be exhausted for the foreseeable future. See, since in Internet of Things, billions of devices are getting added together, and everything needs another address, Internet protocol address. So, if we assign based on the IP version 4, then the address will be exhausted. So, the new concept IP version